Hey guys, great news. OIDC flow now has been enabled for Azure Terraform provider. I'm super excited to see this, and finally, HashiCorp has released this with, I think, I'm sure with the help of Microsoft collaboration because this is managed by Microsoft Terraform provider for Azure. Um, so right now, as we said in the earlier video, right, that the Workload Identity Federation is the future of security for secure cloud deployment, where we are basically going to teach the service principal secrets. So there's no need to actually physically download any credential secrets and bring it outside of the cloud and making it another secret management problem for cloud deployment. Rather, right now we can use short-lived OIDC token and deploy it, and the best part is it is now supported by default with GitHub and GitHub Actions with Terraform. If you recall, I earlier showed a demo how we can use it with GitHub and GitHub Action with Azure AD and Workload Identity Federation feature, and right now it is even done with Terraform, so you can use Terraform, and Terraform supports out of the box workload identity federations with Azure AD and GitHub Action OIDC provider. So if you recall, this is the flow. You can see my previous video where I explained how workload identity federation work, but in this video I'm going to show the demo how actually Terraform you can use the same pattern, and you do not need to have a long lived secrets for the service principal. So few changes in the code. The basic changes right now, this is only supported in the 3.7.0 version. This is currently the supported Terraform Pro Azure Pro RM provider versions needs to be used. I just use the local thing, and that's the simple code to create a resource group, and then rest of the workflow is pretty similar. I'm planning to experiment further with an Azure AKS cluster creations with this workload identity federation, so that's why the name is that. But it's pretty simple, same code. So let's see our demo, right? So if you see, there is absolutely the only secrets we are using in this workflow is client ID, subscription ID, and tenant ID. There's absolutely no secrets is being used, and it's going to work with Terraform. And I'm using infracost also. So I'm going to show you how you can use GitHub Action for a self-service infrastructure delivery. It's very cool. You don't need to install any software. It's a SaaS product out of the box. So let's see a cool demo. Okay. So I'm clicking on this manage AKS cluster, and I can provide any kind of input variables to my GitHub Action workflow. So right now, typically to create an AKS cluster, you can select number of worker node. That will show in a future demo. But right now, what are the three things we are going to do with this Terraform script? Either we can use plan and cost. So let's see the first part, right? The plan and cost, how it will be. How it'll show you. But I think if you do the apply, it does all three together. But let's look into the and the plan and cost. Let's go to the apply first, and I'll show you how this works. So once I select it, I get I need to approve this. So right now, let me reject this because I want to show you one cool things first is before I apply. So I want to show you plan and cost, and one more thing is, so there's three different environment. Let me go to Azure AD, and I'll show you a cool feature. Okay. This is my Azure student account. Thank you Microsoft for giving me the credit for 1 year because I just completed my master. So I have the free credit still left with my institution Georgia Tech, but I just do it for experiment. So let's go to Active Directory and see, and I'll show you a cool thing. Is before I run, just to recapture, right, what's going on. So I have created this app. So, and if I go to certificates and secrets, you see I am actually okay. So right now, if you see, this is supporting destroy, and you can basically add an additional credentials for it. And the way you do that is, right now I'm not doing it. The way you do that is this way: you copy this command, okay, and put it into any notepad plus plus just to create this. And I'm just going to take the last one. So oops, sorry, what is going on? Okay, I think bottom is also copied. I don't need to copy it. Okay, so here I need to use the object ID here, and let's go to this overview. This is the object ID. So I can add an additional credential. So I'm saying Azure Dev credential. That's for the destroy. And I can just say here that Azure Dev TA plan, plan credentials. And that one is going to actually, that one is going to, and if you look into this YDC demo, and I'm going to change it to this. Okay. And then this one, I can just say the environment is, let's see what are the environments I have. I have destroy, I have this one. So let's say I'm going to use this one. Okay. And description is this. So I now should be able to create an additional credentials on the top of that by going to Azure CLI. So on that application, I should be able to use it. See, so right now, let me see what changes. So on the same application, I added another one. So right now, if I go to app secrets, see, I have right now another one, AG day plan credentials. And there I have a different environment has said this is for the plan and cost, and same thing I can do for apply. And the only thing is the environment will be applied here, this one. So the environment is going to be applied, and probably we'll change it here. The interesting thing to note, so you basically create an app, then basically grant some role on that app for the subscription, let's say contributor access, and then you basically create specific credentials which will build the trust between that and see what it is basically saying. If a workflow call is coming from this repository and this environment, you trust it, and that's all. And that's where this is more protected than sharing any password, because you already have a way to implement get an access to that workflow. So that's how it's being triggered. So there is no separate authentication is needed. So this is really the cool, and I feel this is the future of um, this is the future we're heading for cloud deployment. So let me copy and enter. So now I created another credentials, if you notice. So I'm creating actually two credentials. If you go to, so it's the same app, but the app has multiple credentials. So it should be three, right? I mean, that's how, yeah, three. Awesome. So we have an apply, we have this different one. The first one is basically the destroy, but we created it earlier. It's okay. So now I should be able to go and use any one of them. So let's say this is a self-service infrastructure creations. We can select one node, and right now that's not yet implemented. And let's see the plan. Right? Let's run it. The rest of them too is skipped because plan doesn't need any approvals. Um, so it's working. So you can basically run and see the plan, and basically also we included a very interesting feature called infra cost. So basically that can actually tell how much does it cost. um, that's a very cool feature. So I see I'm just trying to create a resource group. So literally there is no cost for it, it's zero. But this is just to show the idea how Workload Identity Federation works with Terraform without even sharing a long lived secrets and with Azure. Um, I mean, I can create another one if we want, like, I mean, the same way we can create another um, something to be created. Let's say I'm selecting this time apply and running. I'll create a resource group because I'm selecting a random resource group name. Uh, so it should be created, and it's keeping other workflows because I have a condition there that if it is only for the certain environment, then allow. We can change that later on, and because sometime before approver wants to approve, they want to see that, you know, the the cost and the plan, and generally it can be done via pull request also, but this is an on-demand workload. So, and by the way, this is the setup is done with the self-hosted runners. So runner is running in a different VM, but the VM has no knowledge. It's a stateless VM. It has no knowledge. It doesn't need anything, any secret. So you can replace that VM with a container or any other thing. And in future, we'll have a demo where we are going to use container as a GitHub action runner. but this is a cool way where we can actually do a passwordless, secure, super secure deployment. And hope you enjoyed this. If two resources is created, and I mean, so we can just go and verify in the subscriptions. The subscription I have is this, using my student account as this. So if you look into this, is the subscription is currently what is called, the one last today created is I think, I mean, these are all random, so this is probably this one, because these are all randomly created. I mean, we can just try that. So probably we can also go and run the destroy, so that it deletes unnecessary, which the I mean, this is just for demo, right? So we can now, and this is a good example of showing the self-service infrastructure, right? With GitHub Actions, so your workflow is literally like a UI where you select whatever you need, and like a push button, you run it, and you have an approval in place, and that's basically done. And you do not need to install any software, and no maintenance, and all comes out of the box. And GitHub, so the public, if you maintain a public repo, it's free. But if you have an enterprise repo, or if you have a private repo, and if you have then you can make it private. If you have an enterprise repo, or if you go for an organizations, then you can do with private also. But remember, for the free version, you cannot use environment. If you have a private repo, you have to have a public repo. And it's okay. GitHub, I mean, it's good to give back to the community. We learn so much from the open source, and GitHub is one of the best contributor for the open source world. So it's good to give back, right? So let's see the destroy. And by the way, the remote state is now, it's managed into a simple local file system in a file. So that's how it is done. So you see two to destroy, because right now only two are there. So this is the remote RG happy. This is the resource group is going to be deleted. And those are Terraform stuff, right? I'm not going into details. Okay, I think destroy is successfully done. Yeah, so hope you enjoyed the quick video. So you this is you can clone. Feel free to fork the repo, and feel free to contribute back, and raise a pull request if you want to contribute back. I'm going to keep improving, doing more on Google side also, and I'll share more on AKS side, how we can use the same thing with creating AKS cluster. Thank you.